Hello, teacher.
Okay. How about Panata? Hello.
Hello, teacher.
Okay. Inpita.
Hello, teacher.
Okay. Why youอื่n? Hello. We have write this from 1, 2, 3, 4, 5.
Sorry, teacher. I forget to change the name.
Okay. And Chakapan, hello.
Hello, teacher.
Okay. How about Dampoon and Percy? Okay, don't worry. Okay. Okay, today I will review about the filtration that I post the video already for a short and give you some example, right? And then we will talk about the centrifugation. Okay, on Friday I will post the video about the cell disruption and attraction. Okay, and also on next Tuesday, maybe I will assign you the homework for filtration and centrifugation. At least 2 or 3 students have to present in the class with online class. That's right. Okay, let's start about the okay, everybody hear the micro point. That's right. Okay. Okay, as I talked to you, right, the step of bioseparation or downstream processing, after you run the reaction by biological reaction, we have like the fermentation broth. That's right. In that, we have a lot of component, right, solid, liquid, gas mixed together. But our product also mixed together. And then the next step, we have to separate, right? We have to separate. First, we have to separate solid out of the mixture. There are lots of technique to separate the solid, right? The first technique that I talked to you is filtration. And the second technique is centrifugation. That's right. But for this, the first I will talk to you already, right, in the video, the filtration. Filtration is the technique that used to separate solids, mostly a large size particle. If the size of the particle is quite small, the next technique is be better for the centrifugation is better for separate a small particle. That's right. In filtration that I talked to you, mostly we have two components like the filter media. That's right. Filter media. And also if the fluid or suspension means a mixture of liquid and solid. That's right. Pass to the filter media, but mostly the filter media only the liquid that the size of the liquid or size of solid that is smaller than the hole or smaller than the hole. You can pass to the filter media. We call the clear solid or clear liquid as filtrate. And the solid that decompose, that's right, or deposit in the surface of the filter media, we call it the filter cake. That's right, the filter cake. But for this case, there are some problems. That's right. If a lot of solid deposit at the surface of the filter media, and then the filtration efficiency will drop because that's right. In the hole, something there are some solid in the hole, and then filtration cannot be done because there is the hole for liquid pass through. And then the technique to improve the filtration, we add some filter aid. That's right. We call this filter aid. Filter aid. We mix the filter aid, or we put the filter aid and in front of the filter cake that we make this, we add some porosity. That's right, a lot of porosity for the solid that's smaller size, and then will be collect in front of the filter aid ก็คือเราก็เอาตัว filter aid เนี่ยมาช่วยนะครับก็คือมาวางหรือมาวางไว้ที่ข้างหน้ามันก็จะช่วยให้เกิดรูพุนหรือช่องว่างให้มากขึ้นนั่นเอง will improve the filtration. Okay. This is a the general principle of the filter. That's right. The most common tool equipment that we use in industry, like in chemical industry, logical industry, we filter, that's right, phase and frame filter. And also the most one is rotary filter. In our pilot plant, we have this, that's right, it's a phase and frame filter. Okay. I also short describe for this. You can study in the video. I will show you some video that's right, for this. This is the most common for the filtration in like rotary drum vacuum filter. This is mode operate continually. ก็คือ operate แบบต่อเนื่องตัวนี้นะครับ Okay, I will show you some video. This is an example of rotary filter. Okay, the first step, right, we flow the water for the liquid, that's right, for the liquid inside the liquid reservoir, that's right, liquid reservoir. In this zone, we call this filtration zone, that's right, filtration zone. Okay, and we have the vacuum system. When the filter rotate, it is the liquid zone. Filter rotate, we have the filtration. If the equipment rotates out of the liquid zone, and then we have like the watching. It's most watching by water. It's watching zone. And then we dewatering, maybe dewatering by the steam, something like this. Okay. That's right. The dewatering. That's right. คือไล่น้ำออกนั่นเอง Okay, this is the inside that we have tube when the filtration, the water or liquid flow in the tube. That's right, the tube. And this is the filter cake or solid that deposit in the filter surface. That's right. We separate by a knife or spike or something like this. That's right. We have knife. It is the example of the rotary vacuum. Okay. Like this. And I show you, right? This is filtration step or filtration zone, right? When the filter medium, right, submerged in the liquid. And also in this side, we operate with the vacuum. When you decrease the pressure until it's vacuum, some liquid will go to the filter medium and go into the tube. That's a solid deposit in the filter medium. And then when the equipment rotate, okay, until this zone is water, washed by water. That's how you spray water toward the cake, and then you dewatering by the heat, like the steam or hot water. And then we have some scraper, that's right, to separate the filter cake. And then rotate continuously. We have like the filter medium without filter cake, and then you can use this again and again. We can recycle with a cycle. That's is filtration zone, watching zone, and dewatering zone. This is more common used in the biological industry. Okay, the next I will show you the example. I talked to you this already in the video, right? The theory, that's as principle of theory. I think from chemical engineering you studied already. In this example, right, we have two conditions. The first condition we have the data from the experimental data or the lab scale. But the question we would like to scale up by using the equipment, by using the data from the lab scale. Okay, from the lab scale, we have 30 milliliter sample of fermentation broth from penicillin fermentation. That's right. We use a filter in lab scale with a volume of filter is 3 area of the filter is 3 square centimeter. This is the area of the filter. We operate with the pressure drop across the filter medium is 5 psi. That's right. The time for filtration is 4.5 minutes. That's right. From the previous study, we have the data that for the compressible factor or compressible constant S is 0.5. Okay. The question is if we scale up from 30 milliliter sample to 500 liter broth. That's right. For the experimental data or lab scale, we only operate with 30 milliliter of the fermentation broth, but now we would like to operate with 500 liter. That's right. We call this our pilot scale of fermenter. That's right. We will filter within 1 hour or 60 minutes. That's right. The question is what is the size or mostly what is the size? We talk about what is the area of the filter. That's right. We operate with two pressure, 10 and 5. That's right. If we operate with pressure drop with 10 psi, what is the area of filter we require? And if we operate with 5 psi, what is the area that we require? It is two questions. But for this case, we will scale up based on the information from the lab scale. Most condition is the same lab scale. That's right, the same lab scale condition. Okay. If we back to our equation, that's right, this is more the equation. And for this case, we neglect the resistance due to the medium. We have no the information, but also in the problem statement, resistance due to the filter medium is negligible for this case. Okay, for this case, we can cancel this term. That's right. We can cancel this term. We have only the relationship between the filtration time, the volume of filtrate, that's right, the cake, viscosity, area of the filter, pressure drop, and concentration. Okay. For this case, for a compressible cake, for this case, we consider a compressible cake because we know, right, parameter S. We know the parameter S. Okay, we consider this is the compressible cake. From the compressible cake, we know from the equation, we have to express this equation by the formula that's alpha equal to alpha that and delta p power s. We know s. For this example, right, we don't know mu f, we don't know alpha that, and we don't know c. For this case, we assume, right, mostly the fluid in the lab scale and pilot scale is the same viscosity. This is constant, that's right. This is constant. And therefore that is also the constant, and concentration in the lab scale and scale we assume constant. We don't know this value. Okay, we can assume this value is constant because it's most common. It's common sense because the viscosity, okay, we would like to scale up lab scale and the larger scale should be the same viscosity, should be the same alpha that or compressibility, that's right, and the same concentration. Okay, for this the same. That's right. Okay. From the lab scale, we know this value or this term is constant. We can calculate this term from lab scale. But for lab scale, we know A, that's right. We know T, we know delta P, we know V. Okay, from the lab scale. We know the volume of filtrate, that's right. This is the volume of filtrate. We know time, we know P, we know S, and then you can solve for mu f, alpha, that, and c from the lab scale. Okay. You substitute T, delta P, Vf, you get this answer, That's right. This value of alpha mu f, alpha that, and c. It is constant. That's why when you calculate based on the larger scale, you use the same value for this. Okay, and then you know the mu alpha c from the lab scale, and then you can calculate the area of the pilot scale by using this term. Is constant. That's why, okay, we back to the equation like this. From this equation, you can rearrange the equation. You get a square equal to this, and then you take square root. That's right. You get take power 2. You get a equal to this equation. So for this case, you use based on the concept that mu f, alpha c, and c is constant. That's right. After small scale or large scale, and then you scale up to the pilot scale. This term is constant. Okay, this term is constant, the same value. Delta p, you know delta p. That's right. From the question is we have 2, 10, and 5. P. For this case, we calculate based on 1 hour or 60 minutes. And VF, VF is 500 liter for this case for the larger scale. That's right. Okay. You substitute this term, you substitute delta P, you substitute VF, you substitute T, you can calculate A. We have two cases, that's right, for 10 PSI and 5 PSI. You substitute 10, 5, you substitute this term, you substitute time, and something you convert the unit. That's right. You're expert already, chemical engineering, now you convert unit. Okay. We get 1.15 square meter for 10 PSI and 1.37 square meter for 5 PSI. You can see that if you increase the pressure drop, that we require smaller area. That's right, smaller area for this case. Yeah. Because 10 PSI, you need 1.1 square meter, and 5 PSI, you need 1.37 centimeter, square centimeter. This is for example when you do the experimental, and then we would like to scale up, because mostly in industry we use a large scale, but you have to know about the large scale first for design and for do aside. Okay, this is an example. Okay. For the homework, I will post in the Google Classroom later. Is maybe about 1 or 2 questions for the filtration. Aside. For this, do you have any question about the filtration? We didn't talk about a lot of the detail for the filtration because you only study in chemical engineering. Okay. If you have no question, I will talk to you about the centrifugation. That's right. If the filtration cannot operate good, that's right. It is not good to operate because it may be some very small particle size. The filter is not perfect for the separate the small particle size. If we have at least 2 techniques. If very small particle size, you have to increase the size of particle by the flocculation that we will talk to you about 2 weeks, the next 2 weeks about the flocculation. You add some chemical, that's right, some chemical or biological substance, add to the liquid, and then some solid will aggregate from the smaller to a bigger size, and then you can use the separation by centrifuge or filtration for that case. And another case you can use by the centrifugation force ก็คือแรงหนีศูนย์กลาง as I will talk to you next. We have 2 techniques. If the mixture, in the mixture we have a small particle, we have 2 cases. To solve this, the first you can increase the size of particle by flocculation and precipitation. Sometimes the flocculation you add some substance or chemical. It's maybe you add some alum. That's right. I think you know about สารส้ม alum ก็คือสารส้มนั่นเอง You add some alum in the water. That's right. There are some solid mixed together from to a bigger size, and then we can separate by gravitational force. ก็คือ ช้น้ำหนักก็ได้ or centrifugation or filtration. This is the another case. Another case we can use the centrifugation ก็คือแรงหนีส่วนกลาง as I will talk to you now. Okay, the next equipment that we will talk about the separation of solid from liquid mixture. That's right. For this case, we use the centrifugation. The technique or the property that we will separate by centrifugation, that is the difference of the density. That's right. We use the difference of the density. And then when the force is greater than gravity is designed. For the centrifugation, we add some force that is greater than the gravity ก็คือแรงหนีส่วนกลางคือแรงมันเยอะกว่าแรง G นั่นเองครับ Mostly in bioprocessing, that's right. We use centrifugation to remove cell from fermentation board because mostly some cell or some enzyme is very small size, especially when you use the disruption. That's right. In the case of intracellular product ก็คือกรณีที่ถ้า product ของเรามันอยู่ในเซลล์ That's right. If we need an intracellular product, you have to disrupt the cell first ก็คือทำให้เซลล์แตก and then the chemical, the substance will release from the cell. Okay, after that we have the mixture of cell debris and product, water and a mixture water. That's right. Cell debris ก็คือเซลล์หลังจากที่เราบดแล้วก็คือเป็นขนาดเซลล์เล็กๆ Cell debris is a very very small cell after this because it's very small size. It's difficult to separate by filtration. That's right. For this problem. Okay. But when you compare between the centrifugation and filter, that's right. The price mostly is expensive than like the filtration. That's right. Okay, if you engineer, you have to consider if you can use the filter or you have to use filter because it's cheaper than the centrifugation. Okay, if it cannot be separated by filter, then you can consider like the centrifugation for that case. Okay, but centrifugation or fermentation boards produce a thick concentrated cell salad or cream containing more liquid than filter cake. Okay, for this case, if we compare with after you centrifuge, that's right, some solid or filter cake will contact with the wall of the tank, something like this. But there are some deposit of the solid, that's right, of the tank. And then you compare the solid of filter cake deposit in the surface of the filter medium. That's right. When you compare this solid, the solid that obtained from the filtration is more thick, that's right, or concentrate than the filter cake, that's right. But in industrial centrifuge, we generate a lack of the heat. Right? We have some friction, we have some resistance, there are some heat generated during you use the centrifugation. อันนี้เพราะว่ามันมีการปั่นเหวี่ยงค่อนข้างแรงมันก็จะมีความร้อนเกิดขึ้นนะครับเนาะค่อนข้างเยอะพอสมควรเมื่อเทียบกับ filtration. Okay, talk to you already. The last this is the centrifuge capacity cannot be increased by increasing the size of the equipment. That's right. It may be it depends on the mechanical strength for this case. It also depends on the mechanical strength ก็คือความเครียดนะครับที่เกิดขึ้นจากการปั่นเหวี่ยงหรือแรงการกลนะครับอันนี้ก็จะมีผลเหมือนกันนะครับ Okay, this is a simple configuration of the centrifugation equipment. This is the tubular centrifugation. So we have some tubular or tube, and then we have some equipment to rotate. That's right. If you rotate, some solid will move in this direction. That's right. Some solid will move in this direction. Okay. After it move, it contact with the wall or the surface of solid, and then we deposit in this, and after we drop by gravity. That's right. Gravity. Don't forget that in our system we have two systems like liquid and solid. After you centrifuge, that's right, both solid and liquid will move to the wall that's right but mostly the move faster is solid ก็คือตัวที่เคลื่อนที่เร็วกว่าก็คือ solid that's right and solid will deposit in the surface of the wall that's right and then we can separate it maybe by gravity that's right maybe gravity and sometimes we have some filter also for this case okay the solid will deposit in this and then you can collect this process that you can use the pump or something to separate solid out of the system. Okay. And another equipment we call it is this stack bow centrifuge. This stack bow centrifuge it look like a disc. That's right. Okay. If you feed the suspension like this and then you rotate this equipment, it flow in this and you rotate. There are some separate solid. That's right. Solid will deposit in the wall, something like this, in the wall, something like this. And also you can throw out the solid. You can collect the solid in this direction or you can collect the solid in this direction. Up to you the design is based on the design. That's right. I have some video, something like this. This is some the example and you feed the mixture. That's right. The mixture. It's also rotate. That's right. Centrifuge. Some solid, smaller solid will collect at the bottom zone or in the surface. That's right. In the surface. And then you can collect it out. That's right. You can collect it out in this or in this zone, or you can collect it out in this zone. That's right. This is the example of the centrifugation. Okay. Mostly the solid will collect that's right, in this zone, and then the clear liquid will flow out. That's right, flow out by pump, something like this, and then you get with the clear liquid, and then you send to the next equipment to separate liquid mixture. That's right. Okay. Another technique that this is this stack bow centrifuge also. This is the same. That's right. This stack bow centrifugation. That's right. And if you feed a mixture of solid and liquid, and then if you have the pump to move out the solid, okay, the direction of the flow in this direction. The liquid go to in this. Right? The solid collect this. The solid collect in this, and then you can pump the solid out of in this direction. You can pump in this direction, or you can pump in this direction. It's up to the design. That's right. It is the example of the centrifugation. This is the centrifugation that's in our pilot plant. For this design in our pilot plant, we have two functions. We use this as the centrifugation, and also we use it as the filtration. Because we use the centrifuge force, and in the surface we have some filter medium also. That's right. For this case, we use two functions, filter and centrifuge ก็คือเราใช้ในทั้งการกรองแล้วก็การ centrifuge นะครับถ้าเราใช้วิธีปั่นเหวี่ยงทั้ง liquid solid ก็จะเคลื่อนที่มาปะทะที่ผนังตรงนี้เพราะฉะนั้น liquid ก็จะเคลื่อนที่ผ่านไปข้างนอกนะครับส่วน solid ก็จะสะสมอยู่บนผิวนั่นเอง For this case we use the turbo centrifuge because we use high force high pressure because we use high force high pressure if we back to the principle like this. We use a very high force or very high rotation, and then all of liquid and solid will contact the surface of the wall. Will contact the surface of the wall. If we use the wall as the filter medium, that's right, solid will deposit in the wall, but liquid will flow out. That's right. Well, we use this centrifugation and filtration together. Equipment. This is quite improve the efficiency ก็คือเพิ่มประสิทธิภาพได้นะครับกรณีนี้ Okay. Talk to you about the equipment, the principle, and it's maybe like the theory. For this case, if you back to control right the flow of solid in liquid, I think you study in like the lab fluidization, the flow of solid in liquid. Mostly we talk about terminal velocity. The terminal velocity. If we talk about the Stokes law, it's maybe the laminar flow. That's like UG. UG is a function of difference of the density of particle and fluid. That's like low P is the density of particle. Low F is the density of fluid. That's like dP is the diameter of the particle. G is the gravitational force. That's right. And viscosity. This is the terminal velocity. Okay. For the centrifuge, this is based on the G force. If we talk G force means the gravity. That's right. G force. This is the separate based on G force. And in the same way, if we calculate the terminal velocity based on centrifugation force, that's right. We call it UC. That's right. The centrifugation UC most is the similar way. That's right. Low P minus low F. That's right. Divided by ST viscosity dP square. But for this is G force, but it is the force for centrifugation. Omega is the angular velocity. That's right. Angular velocity. Mostly we have like the radius per time ก็คือรอบต่อเวลานั่นเอง That's right. And then multiply by the radius of the centrifuge. Omega is the angular velocity. That's right. ก็คือ radius per second. That's right. ก็คือรอบต่อเวลานั่นเองก็คือ1รอบนะครับใช้เวลาเท่าไหร่เนาะ Okay. This is the compare between the force based on gravity and the force based on C. Please remember that this technique we design the force is greater than gravity. That's right. It's greater than gravity. If the force of centrifuge is less than gravity, more solid will drop to the bottom. That's right. But for this case, if the centrifuge force is greater than gravity force or G force, more solid will move to contact at the surface of the wall and deposit at the wall. That's right. This is the technique to separate by the C force and G force. Okay. Okay. For the scale up, when you compare between lab scale and pilot scale or industrial scale, we have some term to compare between G force and C force. That's right. C term or Z term. That's right. This term is the ratio between C force or centrifuge force divided by G force. That's right. This is the term used for compare between, right? Mostly in industrial centrifuge, Z factor from 300 to 16,000. That's right. This for small lab scale. That's right. This for, okay, sorry, this for the large scale. We use maybe about 300 to 16,000 this factor. But for the small laboratory we need higher Z factor ก็คือตัว Z factor คือเราเปรียบเทียบระหว่างแรงจากศูนย์กลางเนาะกับแรงจากแรงโน้มถ่วงเพราะฉะนั้นเราก็ใช้ค่านี้ค่อนข้างสูงเพราะต้องการให้แรงจากแรงโน้มถ่วงนี้น้อยกว่าแรงปั่นเหวี่ยงมากๆเพราะฉะนั้นเราต้องใช้แรงปั่นเหวี่ยงค่อนข้างเยอะเพื่อที่จะให้มันไปปะทะกับผนังนั่นเองนะครับ is a larger size centrifuge we need lower Z factor. That's right. A small size of the centrifuge we need higher G force. อันนี้ common sense นะถ้าตัวเล็กมันก็จะปั่นได้ค่อนข้างสูงถ้าตัวใหญ่มันจะปั่นสูงไม่ได้อยู่แล้วนะครับมีลิมิตของมันอยู่นะครับ This is the most common because the large scale centrifuge we need smaller Z factor. That's right. For small scale centrifuge we need higher Z factor. It's common sense. Okay. For the centrifugation, that's right. The sedimentation occurs in a centrifuge as particle moving away from the center of the rotation. That's right. Sedimentation ก็คือการตกตะกอนของ solid มันจะเกิดขึ้นเมื่อมีการแยกโดยการ centrifuge แล้วมันไปเกาะที่ผนังแล้วมันก็นี่ครับโอเค We can do this by improve the efficiency by increase the velocity of motion. That's right. If you increase the velocity of motion, that means you increase the centrifugation force. You can improve the rate of sedimentation. And also the particle velocity, that's right, in a given centrifuge can be increased by increasing the centrifuge speed. You can increase by the increasing by centrifuge speed, or you can increase this velocity by increase the diameter of particle. That's right. If higher diameter or higher size, the larger size of particle will increase the velocity and also will improve the rate of sedimentation. Okay, another technique, you can increase the different intensity of particle and fluid. If the difference between density of particle and fluid, okay, we improve the velocity and improve the rate of sedimentation. That's right. Okay, when we compare between batch and continuous centrifuge, in batch centrifuge that we use in laboratory, the most in batch centrifuge we use in laboratory centrifuge. The centrifuge time is increased by running the equipment longer. That's right. The batch is depend on time interval. If you operate long time, that's right. If you operate long time, the centrifuge is long time. Okay. We need the time increase and improve the centrifugation. That's also in continuous flow device such as this stack centrifuge. The residence time is increased by decreasing the fixed flow rate. Increasing the fixed flow rate. Okay, for this case, for batch is common. That's right. If you're running longer equipment, okay, you need the residence time is long. That's right. If continuous flow, that's right. If you increase the residence time, you can decrease by the fixed flow rate. That's right. For this case, okay. And another technique used to scale up, we can recall like the sigma factor. We use the sigma factor for the scale up from lab scale and industrial scale. Okay, for this case, we consider for the continuous centrifuge by sigma. Sigma is Q divided by UG. That's right. Q divided by UG. So it's Q is the volumetric feed flow rate and UG is the terminal velocity. That's right. Terminal velocity based on G force. Okay. Okay. If we compare between lab scale and industrial scale, for this case, it use the same effectiveness. That's right. Effectiveness. Okay. The same effectiveness. That means Q1 divided by sigma 1. For example, this lab scale should be the same pilot scale of industrial scale. Q2 divided by sigma 2 for this case. Okay. How about sigma? I will show you the equation like this. Okay. Later. I will show you right how to use the sigma term and what is the equation for describe the sigma term. Like this. Okay. For this case, we use like to separate bacteria. That's why we use bacteria to change some sugar, to change some raw material. That's to be our product. We call the product from the biological reaction of fermentation. We call this fermentation broth ก็คือน้ำหมัก Okay. For this case, we would like to recover by using a pilot plant scale tubular bowl centrifuge. Recover means separation. Yes, okay. By tubular bowl centrifuge, the cell approximately spherical. Okay. We assume the cell morphology is the spherical solid ก็คือเป็นทรงกลม with a radius of 0.5 micrometer. And the cell have a density of 1.1 gram per cubic centimeter. So the diameter of the centrifuge is 10 centimeter. The length of the centrifuge is 100 centimeter. And the diameter of outlet opening of the blow is 4 centimeter. For this case, we operate with 5,000 RPM ก็คือความเร็วของการหมุนก็คือ 5,000 Okay, this means the flow rate of the fermentation broth that can be achieved ก็คือคำนวณหา flow rate ที่เราสามารถจัดการได้ Okay, I will talk to you what is the diameter of the bowl and what is the length of the bowl. That's right. The diameter of the outlet opening of the bowl diameter opening. Okay, I will talk to you. I will back to the tubular bowl centrifuge. This is the simple length of the bowl is should be the high. That's right. This and also this R1. R1 is the opening radius. That's right. From R1. R2 is the radius of the bowl. Okay. This is R2. R1. Okay, from the equation we use sigma equal to Q divided by UG and sigma equal to omega square V. How to know what is this value? I forgot to show you. I show you in my lecture note already. In this, I put in the Google Classroom already. You can read from this lecture. That's right. And also from the chemical maybe design one. That's right. I show you in the lecture. This I put in Google Classroom already. This is more of the equation, model equipment. That's right. The equation I show you in this lecture note already. You can collect from this. And another example you can read from it. We have more than one example in this. That's right. This I collect from the first example we show you in the slide, but you can read by yourself for another example for this case. Okay, another example. Okay. What is the sigma? What is the Q? You can collect from my lecture. Okay. I put in the Google Classroom already. Okay. For this case, as the sigma equal to Q divided by UG, as and sigma, what is the sigma? Sigma is omega V, omega square V divided by 2G log R2 divided by R1, and also equal to this if we do the tubular bowl. For tubular bowl, we can use this formula. We can use tubular and this UG. And for the example, viscosity is approximately 1 0.01 gram per centimeter per second, and density is 1 gram per cubic centimeter. Because this is, we have no the data for it. Okay, we can assume it the property. The first step, you calculate UG. Calculate UG. You know low P, you know low of water, which is low of water, this low particle, right? And diameter of the particle, and G divided by viscosity, and then you change the unit. And then you get low G. Sorry, you get UG, this term. And then you calculate sigma. For sigma, for the tubular bowl, we use this. Okay. This is RPM. That's the revolution for minute from the problem. And we know, right, 1 revolution equal to pi radius ก็คือ1รอบก็คือ2 pi ถ้าจำได้นะครับ convert in unit. That's right. You know, right, from the problem statement, it's 5,000 RPM, but you know that 1 revolution equal to 2 pi is radius unit. Okay, multiplied by pi, and you know B. That's right. You know R1 and R2. G, R1 and R2. That's right. And then you convert unit. You get sigma equal to this. And then you can calculate Q equal to UG sigma. You get flow rate. That's right. You get flow rate. Because the question is, what is the flow rate of the fermentation board that we can retain? That what that means ก็คืออันนี้ก็คือว่าเราถามว่า flow rate ของน้ำหมักเท่าไหร่ที่เราสามารถที่จะ operate ได้นะครับด้วยความเร็วรอบ 5,000 RPM นั่นเองนะครับเราก็ใช้สมการนี้ได้สมการทั้งหมดเราไปดูในชีตนะครับที่อาจารย์ให้ไว้ใน Google Classroom อาจารย์ไม่ได้แสดงเป็นต้นนะครับอาจารย์ก็จะอธิบายแค่บางส่วนเพราะว่าเราเรียนมาแล้วในนักเรียนนะส่วนทางปิโตรเคมีคอลอาจารย์ก็จะสอน Unit Operation เทอมหน้าอีกทีหนึ่งนะครับโอเคI finish the
Sorry, teacher, I can't hear your voice.
Sorry. Okay. I forgot โทษทีนะครับเมื่อกี้มันเน็ตหลุดโทษทีครับอันต่อจากบ้านโอเคI will give you some the and centrifugation on Thursday or Friday. That's right. And then you submit in Google Classroom on Monday. And also on Tuesday morning, I will assign about 2 or 3 students to present homework. That's right. One question per one student is maybe 2 or 3 students. That's right. Okay, I will assign in the homework already. You know who will present on the next Monday, next Tuesday. ก็คืออาจารย์จะให้ชื่อเลยว่าใครจะพรีเซนต์อังคารหน้าเนาะนะครับอย่างที่อาจารย์บอกมันก็จะมีเก็บคะแนนการพรีเซนต์กันบ้านด้วยนะครับโอเค Do you have any more question? Moreover, for this, I will post the video for the next lecture. That you have to watch some video first, and on the next Tuesday, I only conclude some point and give some example ก็คืออาจารย์ก็จะมาพูดสั้นๆนะครับมาสรุปสั้นๆอีกทีหนึ่งนะครับเนาะ Okay, on Friday, I will post like the video for fluctuation. That's right. And attraction. The fluctuation indicate of when the very small particle or very small solid, that's right, mix in the liquid, but it cannot do by filtration or centrifugation. You can increase the size of the particle. That's right. After the particle increase, you can remove by filtration, you can remove by centrifugation or by the gravitational force. We call this the fluctuation. ครับมันก็คือเหมือนเราเอาสารส้มไปเขย่าแล้วก็ให้พวกของแข็งในน้ำมารวมตัวกันจะคล้ายๆกันนะครับแต่โรงงานอุตสาหกรรมมันก็ต้องใช้สารอย่างอื่นด้วยเราเรียก fluctuation and then we talk about the cell disruption and fluctuation แล้วก็ attraction เป็นอาทิตย์ถัดไปโทษทีนะครับ okay. You have any more question? If you have no more question, I will stop the class now and see you on Tuesday.No question, right? Okay. Okay. Thank you. Percy, I will stop the card. Yes. Okay. If you have no question, I will stop the card now. I see you on Tuesday. Okay, and please submit the homework by Monday. Okay. ไม่มีแล้วเนาะโอเคครับจักรพันธ์มีอะไรไหมเดี๋ยวจักรพันธ์อาจจะให้พรีเซนต์ตัวเปเปอร์เดี๋ยวคราวหน้าแล้วกันนะครับแต่คราวนี้เอากันบ้านไปก่อน
ครับไปค่ะ
Percy hello Percy
Hello.
Why you enter the class now because we start from 9 to 10 we will stop now because we start the class on 9 to 10 that's right not 10 to 11
Okay. Yes. See you, teacher.
Okay see you next Tuesday okay แค่นี้นะครับเดี๋ยวเจอกันอังคารหน้าเดี๋ยวอาจารย์ให้การบ้านไปนะครับอย่าลืมทำพรีเซนต์เนาะนะครับออนไลน์นี่แหละนะครับโอเคครับ